right, let's go ahead and get started. I want to welcome you to this worksheet. This is mole conversions. In previous worksheets, we've looked at the relationship between mass and moles, and we said that molecular weight makes that conversion. We can look at the periodic table and determine the molecular weight of a specific element or maybe a compound by adding up the component elements, and we went through molecular weight to go from mass to moles or moles to mass. To go from moles to particles, we said that 6.02 or 6.022, you can use either one. 6.02 times 10 to the 23rd we'll use in this particular worksheet because it's written on the worksheet right there. It doesn't really matter. But the point is that that's the number we're going to use to go from moles to mass, or moles to particles, I should say. Let's take a look at number 1. It says 1.4 moles of sodium hydroxide are needed to make a solution for a lab. How many grams of sodium hydroxide are needed? I like to circle what I've been given and then underline what I'm looking for. In this case, I'm looking for grams of sodium hydroxide, but I'm going to start with 1.4 moles of sodium hydroxide. I'll put that over 1, and then whatever unit is in the upper left is going to go into the lower right of the next unit being multiplied. So that allows me to cancel moles of sodium hydroxide with moles of sodium hydroxide, leaving me with what I want, which is grams of sodium hydroxide. Let's talk a little bit about how I determine this 40.01. Remember, this is a compound, so it's not as easy as just looking at an element. I have to add up the component elements. So in this case, it's 23.00 for the sodium, 16.00 for the oxygen, and 1.01, I should say, for the hydrogen. When I add those up, I get 40.01 grams per mole. Grams is what I'm looking for. So now it's just a matter of getting my calculator to multiply 1.4 by 40.01 to two significant digits. I got 56 grams of sodium hydroxide. Check that on your calculator. Let's look at number 2. It says the mass of a solid copper penny is 3.46 grams. So I'll circle that because that's the number that they're giving me, 3.46 grams. How many copper atoms are in the penny? So I'm looking for the number of particles in this case. So I'm going from mass to particles, but to do that I have to go through a moles intermediate. All right, let's take a look at how that's going to happen. I'm going to take what I know, which is 3.46 grams of copper over 1 times whatever's in the upper left-hand corner, whatever unit is in the upper left-hand corner, I should say, goes in the lower right-hand corner. Whatever unit I want goes on top. Now I have to go through moles because I can't go directly from mass to particles. I have to go through the moles intermediate. So I'm going to cancel grams of copper with grams of copper, and I've got moles of copper as my intermediate. So I'm going to have to take another step. So times whatever unit's in the upper left goes in the lower right of the next unit, and I'm left with atoms of copper. 6.02 times 10 to the 23rd atoms of copper per mole. And so now it's just a matter of multiplying what's on top and divided by 63.55. I get this number, 3.28 times 10 to the 22nd atoms of copper. And number 2 is done. Let's look at number 3. Number 3 says a helium balloon contains 16.9 liters of helium. Now that's not what I'm used to seeing, but I'll work with that because that's what I've been given. I'm also being told that each mole occupies 22.4 liters. How many atoms of helium are in the balloon? So I'm looking for atoms of helium. An important note is this. 1 mole of any gas, it can be ammonia gas, it could be hydrogen helium gas, it doesn't matter what kind of gas it is, they all have the same volume, 22.4 liters, so we'll keep that in mind. Let's start with what we know. We've got 16.9 liters of helium over 1 times liters of helium in the upper left, so liters of helium in the lower right. So these are going to cancel, leaving me with moles of helium. That should be an E right there. Moles of helium at that point. So I'm going to go through the moles of helium intermediate to get to what I'm looking for, which is the number of atoms of helium. So upper left, 1 mole of helium upper left, 1 mole of helium in the lower right, and I'm looking for atoms of helium. There are 6.02 times 10 to the 23rd atoms per mole. At that point, I'm done. Let's get to the calculator and multiply 16.9 by 6.02 times 10 to the 23rd. Hit the equal button and then divide by 22.4 liters. I get 4.54 times 10 to the 23rd atoms of helium, and that problem is done. Let's move on to number 4. Number 4 says a vitamin contains 0.300 grams of calcium. So that obviously is what I've been given. Find the number of calcium atoms, right? Find the number of calcium atoms. So I'm starting with grams, and I'm trying to get through to atoms, but I have to go through a moles intermediate. So 0.300 grams of calcium over 1, upper left corner, upper left goes lower right, that's units. So grams of calcium here goes on the upper left, so grams of calcium in the lower right. I'm going to go through moles intermediate. How many grams of calcium does 1 mole, how many grams is in 1 mole, or what does 1 mole of calcium weigh? On the periodic table, it will tell you it's 40.08 grams per mole. This will cancel with this, leaving me with moles of calcium. Then what I'm going to do is take one more step. There should be a line right there. 6.02 times 10 to the 23rd atoms in a mole. This will cancel with this, and I'm left with atoms of calcium. So when I do that multiplication and then divide by 40.08, I get this number, 4.51 times 10 to the 21st atoms of calcium, and that'll do it for number 4. Let's look at number 5. What is the mass of 8.07 times 10 to the 24th molecules? That's what I've been given. I'm looking for mass. So 8.07 times 10 to the 24th molecules of oxygen over gas over 1. Whatever's in the upper left goes into the lower right, right? So I'm looking for mass, and I'm starting with particles, so I have to go through a mole intermediate. Molecules and molecules of O2 will cancel away, but moles is still not what I want. I want mass. What is the mass in grams? So I'm going to put, again, in the upper left, lower right. So now what I'm going to do is I'm going to calculate the number of grams that 1 mole of oxygen gas weighs. Just a word of caution, it's not 16 because oxygen is diatomic. You're going to multiply it by 2, you have 32. So 8.07 times 32 divided by 6.02 times 10 to the 23rd gives you 429 grams of oxygen gas, and you're done with number 5. Let's look at number 6. Determine the volume of 2.6 mole sample of aluminum if the density is 2.7. A little bit different than what we're used to, but we'll work our way through it. That's what I've been given, 2.6 mole sample of aluminum. They're telling me also that the density is 2.7 grams per cubic centimeter. That's a ratio that I'll need to solve this problem. They want me to determine the volume this time. Never done that before, so let's see how this is going to work out. I'm going to take what I know, which is 2.6 moles of aluminum. I'll put that over 1. Whatever's in the upper left-hand corner goes into the lower right-hand corner. And then I'm going to determine the number of grams that this aluminum weighs by putting grams on upper right. So from the periodic table, 1 mole of aluminum weighs 26.98 grams of aluminum. That allows me to cancel these, and I'm left with 70 grams of aluminum to 2 significant digits. That decimal must be there. 70 grams of aluminum then times, now look what I do with the density. They're telling me the density is 2.7 grams per cubic centimeter, but I'm going to flip the density so that I can get cubic centimeters on top. So grams of aluminum on bottom, grams of aluminum on upper left, lower right. Now if I flip the unit, I have to flip the number too. So the 2.7 goes on bottom, 1 goes on top, and I'm left with cubic centimeters, which is volume. When I multiply those 70 times or divided by 2.7, I get 27 or 26 cubic centimeters. And that's the volume that I'm looking for. Let's look at number 7. Calculate the moles present in 14.7 grams of calcium nitrate. The challenge here is to determine the formula for calcium nitrate. I've been given the 14.7. I want to determine the number of moles, right? So calcium nitrate, as it turns out, calcium has a charge of +2, nitrate -1. When you do the switch, you get CaNO3 2 times, just like that. So they're telling me I've got 14.7 grams of calcium nitrate. I'll put that over 1 times whatever units on the upper left goes in the lower right. So grams of calcium nitrate, grams of calcium nitrate. On top, I've got moles of calcium nitrate. That is what I'm looking for. Now I have to determine the number of grams that 1 mole weighs. I'm just going to add them up. Calcium 40.08, right off the periodic table. Nitrogen, notice in the formula, nitrogen is present twice. It's in the parentheses, and there's a 2 outside of there. So I'm going to say 14.01 times 2 is 28.02. For oxygen, it's times 6. There's a 3 here and a 2 here. So 16.00 times 696, add that up, you get 164.10. Divide these two numbers and you get this number, 0.0896 moles of calcium nitrate. That is the correct answer to the correct number of significant digits. And now we go to number 8. It says one type of penicillin has the formula C14H20N2SO4. Wow, that's a big formula. That is penicillin. How many molecules of penicillin are in a pill containing 300 milligrams? We're going to slow down a little bit here because of the fact that this is a particularly difficult problem. They're asking me for molecules. They're giving me milligrams of penicillin. So I'm going to start with what I've been given. 300 milligrams of penicillin, C14H20N2SO4. I'm going to put that over 1. Then what I'm going to do is convert into grams, okay? Because milligrams is not going to help me. I need to get it into grams. 1 gram is 1,000 milligrams. So these two are going to cancel away. And I'm left with grams of penicillin. Now what I'm going to do is convert that into moles. I'm going to go from mass to moles. Now I've got some heavy-duty calculations here because of the fact that, well, I've got a lot of atoms. 14 carbons, 20 hydrogens, 2 nitrogens, a sulfur, and 4 oxygens. When I add those up, however, I get this number, 312.43 grams per mole. So now grams and grams are going to cancel away, and I'm left with moles of penicillin. I'm almost there. I'm looking for the number of molecules or particles of penicillin in a mole. So what I'm going to do now is I'm going to convert from moles to particles. In the upper left-hand corner, I've got moles of penicillin. Lower right-hand corner, I've got moles of penicillin. On the top, I've got 6.02 times 10 to the 23rd molecules of penicillin, or C14H20N2SO4, per mole. So that's what I'm looking for. I'm looking for molecules. So now I'm going to get my calculator out, and I'm going to multiply 300 times 1 if you want to, times 1 again if you want to, times 6.02 times 10 to the 23rd, hit the equal button, then divide by 1,000, and then divide by, hit the equal button again, and then divide by 312.43, and what you get is 6 times 10 to the 20th. Now you might ask, why just one significant digit here? Remember in the 300, there was no decimal there. And because there's no decimal, only the 3 is significant. And so my final answer, my final correct answer, is 6 times 10 to the 20th molecules of penicillin. And that's going to do it for us. I'll see you in the next one. Thanks. Bye-bye.